Yeah, hello everyone. I'm Bogdan Maheros, and this is the Data Storyteller community. So if you can hear us and if you can watch us, just type something in the field where you can type questions in the chat field. And let me remind you that Data Storyteller is a community that unites people working in the data area. So this is business intelligence specialists, data analysis developers, big data, data science, people working with clouds, etc., and etc. And we are usually running our sessions in Microsoft Teams, but today we are going externally in YouTube. So we are very happy that you join us. So if you can hear and watch us, just type something in the comments of the stream. So today we have a great speaker, Katalin Georgio, who is a Microsoft MVP, who is a solution architect. And today we have a very interesting topic, KubeAI. Katalin, what is it? And how can we deal with that?
Uh, So and I'm not sure how I was sharing my screen. Yes.
Yeah, it's
So
working.
we're talking about Khan, and uh, the biggest question around it's why Captain Kirk is yelling Khan. So for this, this is a good idea from a good friend Andre. Uh, so let me try to tell you why it's Captain Kirk is yelling Khan because he cannot yell KubeAI Application Nucleus. Uh, so uh, that will be, and this is the subject of our session, right? And that's what, let's say, a joke to start the session. What we're going to talk about, it will be about computer vision, edge AI application, and especially Khan. So let me reintroduce myself. I'm Katalin Georgiev. I'm solution architect at the PAM. From there, 2011, Microsoft each year awarded me the title Microsoft Most Valuable Professional, and also I'm Intel Software Innovator and Microsoft Certified Trainer. Okay, why it's now the moment to talk about computer vision and all the stuff. So the hype it's in the AI that it's pretty clear, but everybody's talking more or less about ChatGPT, and by extension, we're talking about copilots and some other application of this kind. Yes, these are interesting, but these are new. These are, let's say, are not yet at the plateau of productivity. Computer vision, custom vision, it's there. What's in short computer vision, custom vision? It's to get something from an image. Uh, and how we gonna do it? So let me share everything because anyhow, the rest of the slides are pretty much interesting. Something like this. So let me share uh, all the stuff that I have here, all the screen. So not Chrome Tab, entire screen. So let's do share. Whew. And um, let's start with some terms. Um, this is an external website. This I'm showing to a lot of conferences this website, not about the library, but about how well are presented the concepts. So in let's say in computer vision, custom vision, in some cases, we're gonna see this nice square stuff. And this means that the model has recognized there something. And okay, but that's not the only way when computer vision manifests itself. So we will need to get a couple of concepts. This is classification, localization, detection, segmentation. I like here the picture, but I'm not always agree with the definition below. So classification, what it means? It means that you have an image, and the artificial intelligence will tell you that there are several objects into it. Does not tell you where it is, does not give you a bounding box, does not tell you anything more, but tells you there is something there. Second, it's localization. Localization with a single object gives you a bounding box. If we are talking detection, we use it in the when we are talking multiple objects. So each object will have a bounding box. And the last one, which is the least used in my experience up to now, it's segmentation. Segmentation, it's really try to not to use the normal bounding box, but just to run it around. So here we have the concepts of AI. Let's talk about outside of the data world a bit, about what we're going to do to recognize this. In the Microsoft world, there are now more or less two, let's say, two ideas to do this. What I mean by this, to do inference. Inference, it means getting an image, or in fact a stream, and getting the classification, detection, or the localization out of it. This is the process of inference. And there are two proposals. One will be part of the solution accelerator. They are both open source, which it's the solution accelerator for 5G, which has this capability. And the second one, it's CAN. It's KubeAI Application Nucleus. Okay, I will throw you a bit the architectures. Let's go to the first one. What we need here to see, they are both. I did not show the other one, but let's get the common part. They are working on RTCP streams. All the cameras that we see around us, even the camera I'm speaking, it's exposing an RTCP stream. Second, everything needs to have a frame splitter. So this inference, it's not done on the stream as it goes. You need to get one image, and on that image to run the inference, and then to get the next frame and run into it. This is part of the both systems. And then start the differences. Both are container application. The solution accelerator has also the alert mechanism, and it's more on microservices architecture. The CAN, which we're going to talk today, does not have the alert part, but it's more close to, integrated with Azure and also with Azure IoT Edge. Okay, to understand what's the purpose and life of first of Azure IoT. Azure IoT, it's a bunch of services, mostly grouped around the IoT Hub, which take care of ingestion and processing, also updating and monitoring of devices. The ingestion it's a problem because as first ingestion it's affected by very variable rate of getting data. So for this IoT Hub, it's able to scale nicely and to do all the stuff. And second, knows a lot of protocols from the MQTT, MQTT, HTTP, all stuff. Okay, so there are a bunch of services for provisioning, for which most of them rely a bit on the IoT Hub. Okay, what's Azure IoT Edge? So always the discussion was, can we use Azure IoT for real-time scenarios? And usually the most common answer from Microsoft side was, there are latencies. So it's IoT Hub real-time. Now, there are latencies. Okay, to get it, IoT Hub, it's not real-time, but it's very fast because it's a queue system. But okay, Microsoft, to get out these latencies from the discussion, what they thought? They thought, let's run part of these services, because we do not need to get all the data to the cloud to process it. We can process it locally. And their idea was to package IoT Hub to create another container, which it's the, let's say, the runtime of this system, and to enable the cloud IoT Hub to deploy all this. So Azure IoT Edge, it's a collection of containers running in different hardware. And also this is managed from the cloud. You do the updates, you do the push, you do the stuff. You need at least 2 or 3 containers. One is the IoT Hub on the edge. The other one is the runtime. And the third one, I'm still debating for what it is. And the rest, it's your deployment. So whatever payload you want, for example, a model to do inference on top of it, some other stuff. And Khan, from the box, knows when you do the setup, which I'm not going to show you how to do it. You have an option. You want to run it on an edge device, or on-prem or on Azure. This is the first one. And second, when you're running, when you create a compute device, could be a container solution, or it could run on the edge. So this one, it's closer to the edge. But I talked a lot. So let's go to stuff that I'm not gonna show. It will be the installation. But we install it and it's running. Okay, this does not have yet security, but you find it here on the GitHub. How to lock it down. Second, and to finish the comparison between 5G and CAN, let's see when they did the modification. Let's say they modified the installer something like 2 months ago. On the 5G, it's something like last week, 3 weeks ago. And what is this? There is another approach in enterprise development, and not to do stuff in your machines. You go to GitHub Codespaces, which would be a virtual machine connected to something, and which you have everything. So you just connect to the cloud and you get the machine. The other will be the developer dev box, and you have there a developer portal. And from the developer portal, you see your dev boxes when you have full environment provision and everything, and all the tools to run your code. And these both ideas are from Microsoft. It's not the scope of this presentation to go deep into it. Most probably will affect also the database developer, because this concept of never installing anything on your machine, or just use something provision, it has some interesting, let's say, and alluring characteristic for an enterprise and for enterprise development. From security to maintainability, it always work, and we can ship your PC. Because these are virtual machines, and also we streamline expenses, but let's not get into it. Get back to the portal. So let's create a device. Here you see we have the two options. We can do an IoT Edge device. So we can prepare a deployment which will be deployed on an edge device someplace. This won't be the case right now. Let's add a Kubernetes device. So let's say storyteller device. And let's see the acceleration. Then the CPU. What's the story here? The inference, it's best done in hardware. And they suppose that it's possible that we have a server would have this special NVIDIA chip. This special NVIDIA chip makes it very fast to process a lot of cameras. There are already servers which have this special chip, or the vanilla CPU way of doing things. Here, you do not have more to set up. We just create. Second, let's go to camera. Camera. This is from yesterday. Let's delete it. Yesterday I did a similar session, but I was focusing more on the pluses and minuses of the both solution. Okay, let's see what's all about. Everything revolves around RTCP. And we're going to use two real-world cameras. And let's see what the camera sees. One option is to get rid of this. Sorry, it popped up. Let's use VLC. And let's see if the cameras are active. We need to wait a bit and see what's happening. And I won't lose the time. I will put also let's say camera 1 and put the URL. These are from the URL inferred. Where we want to run it. So we want to run it here. And here we're going to pick a location. This is the real location. It's in a town. Here, bear in mind that the both solution, which I mentioned, are rough of the edges. What this means? This means that they are not quite absolutely complete. In the case of Khan, for example, you cannot edit a location. You just create, but it's just a string. So let's review and create and try to look at if we have the VLC. Yes, we have. So this is real park. So let's try the second camera when this, let's first click. Now, click, have everything prepared, but besides this. So add another camera and get the second string. And let's see what's happening. So now we'll open the second one. Again, I must emphasize that all cameras know this protocol. This is how they are sending data. And as this was thinking, we'll get back to the cats, but later, because we'll have a talk about the cats, a discussion. So again, we want to run it on this device, and the location, let's pick this one. And let's see if we have something. Okay, this one, it's not working. So let's not waste time with it, and we won't create it because it's offline. Again, during the installation, you will be asked if you're okay to use an external service to do the frame-by-frame stuff. And if you are okay, it means that, okay, besides that the stuff will work, you'll have also this splash images. Now, this takes some time to get the images and to do the stuff. Second, we're talking about models. So let's delete this and create it again. If you create a custom model, we can use one that you have created from the Azure Custom Vision. And here we have the cats. So here we do not have much more to do. Just to say preview and create and wait. We have two options, cat detection and cats. This one won't work. And because again, it's rough of the edge. But let's see the both models. So let's go. Again, for a data scientist, if you're a data scientist, custom vision, it's a bit down, but a custom vision.ai this. But it works. So you can start with it, and also it has a low entry level. How the stuff works. This is free for 2 projects, but you need to have an Azure AI subscription. So you pick what will be the type of the model. It will be the object detection or classification. So and this tool helps you to do the labeling and to test your model. In object detection, let's see. We have untagged images. When you add the image, you can put pick the labels, and also it's a much more let's say friendly than the label img. So let's try to see what happened. So if you have region show, but this is pretty much default, but you also have a co-pilot assistant type. So if we have suggested objects, they try to do the labeling for you. So for example, this one, it's okay. This one, it's not. But you can pick this one, and you confirm that this is okay. Bear in mind, in detection, you need to put also the bounding box and the label. When you all finish, you're running trainings, and afterwards you can see the performance of the model. So precision, recall, stuff like this. Let's get back to the other one, which is classification. Classification means that it's something in the image. Here, the Copilot does not work. So here you need to have the labels. Dool is the name of the cat. So you can say that, okay, here you see it's already labeled. It said that it's Rejan somewhere in the picture. Does not say where it is. This is the difference. So let's try an untagged image and let's see what's happened. Example here, if we try suggested tags, this usually, in my case, does not work. Not sure what's happening. But this goes forever and ever and does not get any suggestion. What here you need to have? You need to have also the negative image. And also, let's see the performance of the model. Oh, you see, not bad. Okay, getting back to this. We have created the model. Also, you have seen the mention of model zoo there. That's a story that it's a bit long story that starts with Intel. Intel started early in the inference world, so they have a lot of offerings. They have CPU, they have GPUs, and also they have this. I'm not sure that you see it. This is an Intel neural stick. And the problem it was that you need for everything to know. To all this library, they have different libraries, they have different methods of working stuff. So they created a unified platform called OpenWino. And internally they are modifying they create an intermediate representation that afterwards they optimize to the end target hardware. Everything is nice, but they discovered that is an issue, still a barrier to use this. There are no models to try. So they created a model zoo. And these are a couple of the models in the model zoo. They are not all. There are just a couple of them, say, already imported in CAN. So we can use also this, and we'll do this now. So let's here do some cleaning. You see that deleting goes wonderfully, and I was under the impression I did the reset of this demo, especially because I will explain where we're going to see the finish of it, and finish will see it from a real-world solution. So let's create an AI skill. So let's call it data storyteller skill. That sounds nice. And here we have the acceleration. Depends on the device. You see that it supports, NVIDIA, the CPU, the Jetsons. I'll say in the now, NVIDIA seems to have an edge in the inference devices. But okay, in our case, because we're running container and running the cloud, let's put it CPU. And that was the boring part. So let's do the AI skill. For sure, for an AI skill, we have the camera input. Then we should run the model. So so we'll take an object detection, and when we pick the type of the model, we see what are the options. In our case, let's pick this one, because in our cameras, there is a fat chance that we're going to be see any cats. And well, we'll see what are the tags inside, vehicle and pedestrian. Then we can do this also. So we can have an endpoint that will do additional processing on the image. So a container, process frames. In fact, this should be maybe here if we want to have it, but we do not have it. What's important is the filter. To understand in computer vision, custom vision, in general in IE, you do not have uncertainty. You do not have an answer of yes and no. You have a percentual answer. So this bounding object bounded in this box, it's 80% pedestrian or 60% of pedestrian. You never see it 90% pedestrian. So in fact, you'll see it 90% and you see 100%. So you're talking about probabilities. And filter will filter low probabilities and negative. So let's say pedestrian and vehicle, and let's put a confidence threshold of something like 80%. So when there are these labels and it's a good confidence, we'll get it out. So what we can do here, let's start from the last. So let's see, we can have an endpoint URL. That endpoint, what we use it in practice will be the simplest. It's an Azure function with anonymous or function authentication. You get, again, custom vision models give you an JSON, which is pretty standard in format. It has also, we'll see them. I will show you from the real world how they are looking. Generally, it has the bounding box, it has the label, and sometimes has the confidence and some other information. So you get a JSON, you process it, and you do something else. The second one, IoT Edge module. What is this? Remember, IoT Edge, it's a collection of containers. So you can have a skill, a module, a container that you deploy this that will do this processing. This could be a lot of, you can do a lot of stuff with it, but you need to create it externally. So you need to specify the name, the input, and what's the delay buffer. Okay, but bear in mind that it works in IoT Edge deployment. And then send the insights to IoT Hub. This for me was the most puzzling one because it has no parameter whatsoever. Because I was expecting connection strings of sort of and stuff. Yeah, it sends the insights, but it sends the insights to the IoT Hub inside the IoT Edge deployment. So there it is. You cannot specify from this interface one in the cloud. And the one we're going to use, because it's the simplest to show after we delete this, even though I will explain why we won't use what we constructed now, but we use something similar. This one, export video snippet. And what we have, we can say this what it takes. When you create CAN, you are asked for a storage account. And in the storage account, as blobs, you will get the recognition file. And what you can, let's say, data s, that will be the prefix of the file, MP4 files. And this is the snippet duration. How long will be the video? If we want to have the overlay, this what means. If we want to have the bounding box and the probability, and yes, we want, and let's say we want to have it 10 seconds, and we do this done. Review and create. And okay, we done this. Let's assemble this and deploy it to something. So let's have data story develop, and here if we have more cameras, you can link all the cameras to the deployment. So this camera, the camera now it's done. Let's add the skill. Again, if you have more than one skill, you can run both skill on it. And this is pretty much it. And here we're going to stop. What's the problem? Because the cameras are used in a real-world environment, real-world deployment, if you add another CAN to it, this won't get the data. So you can have a camera shared between multiple deployments and multiple skills and stuff like this. That's no problem. But when you go, if you have 2 CAN instances, that is a problem. So these cameras are already using something else. So let us show what that something else it looks. Here are the camera 1, camera 2 is the same location. You more or less recognize the image. Let's see if what is the current image, if we got it here. We got it. Yes, we got it. Now we have the auto. And also here I can show you that you have also the playback option. These are not very good. Talking about history, these both offerings came after a hardware offering called Azure Percept, which had a better way of doing debugging, which was discontinued. So there we have the hardware, which was running IoT Edge, and you run all this, and you have a similar portal to be able to pick the custom vision solution or some sample one and to run it on the device, and you have a way of checking live the inference result, which was far better for presentation and for debug. So this takes some time. So the model here we'll see exactly the model, but if we are looking at AI skills, in fact, let's this is the production one. It's not the interesting, but this is the one that we did similar to the one I did. Okay, let's go edit AI skill. If we recognize it looks similar. What you have here, we're also sending to a service bus queue. Here, I'm gonna just show you. It's just a function of some sort, and goes and sends to a service bus queue what he and also save the video snippets. And let's look at the deployment. Um, how it looks. Again, I'll say this is rough at the edges. When you update the deployment or AI skills, sometimes visually the deployment will remain as deploying. If you change the menu, or if you are looking at here at the definition, it will say deployed or running, not deploying. So this is how you know if this finished. But let's look what we have in the deployment. So we have the two cameras. We have the AI skill. This is again a bug. You do not see the name of them, but they are both. And pretty much this is it here. So let's see what's happening. And let me try to find. So we are getting, this is the Azure account associated to the other instance of account, the one is in production. So let's first see what happened. And let us remind ourselves, this we can close. Yeah, because here we have seen the cats are very nice. Anyhow, Bogdan told me that he will stop the session if there are no cats. So I obliged. That was a joke. And let's double check what we have put here in AI skills, like prefix. So edit AI skill, drag and drop nodes. So properties, pers, weg. Okay, let's see what we have. Getting back to this. So let's look at block containers. So, and let's now we're doing this model from the model zoo. It's far from perfect. Okay, there is, and we'll need to hunt one which works. What's the problem with the model zoo models? Yeah, bear in mind that these are just for demo, general. For example, the one, will I pick? The one with the car number plate recognition that you have an open vinyl, it's trained in China. I'll say that's nothing bad of being in China or doing something, but if you are in Europe and you are giving an European number plate to the model won't work. Why? Because Chinese number plates are blue. And okay, that tells you two things. You need to train with a lot of picture the model, and second, it will be an idea to pass a filter. You say that, and this is, bear in mind, if you cannot set the camera of doing this, you can do this. In this specific case, we did not do this because the advice of the domain specialist, in this case was agricultural, was that they need the color. In black and white, it's not enough, let's say, information. And also was somehow easier for them to discern and double check the module afterwards. So let's try 3 more. And if we do not find no one that shows a real person, we'll move on. And also the advantage of one, let me try to have one bigger. Or older. Because that will show you also the probabilities which are on top. So let's see this one. Again, this part of the, and 2 more tries, and we'll move on. So let's see if demagogues are around. Let's try again. Not sure why. What was with that? And okay, it will be the last try, but now I will create a new folder on the desktop, which is yeah, I need. Okay, always find a way of getting to the desktop. So let's see the last try. No big hope. Okay, we think that this model is a bit flawed, but just remember that we have the endpoint that writes to a storage bus queue. So let's go there and see what we have there. Besides a lot of data, so let's go to the queue itself. So you see, it's recognizing a lot of stuff, a lot of false positives from the normal, let's say, the Zoom model. But as demo goes, it's far better to have something moving than nothing moving. So again, a lot of activity. Let's try to see what we have in the queue. We have a lot. Let's pick a message. So it gives you the, let's say, the bounding box, and some other information, and the skill that generated it. The skill will help if you have different skills doing different stuff. The way of showing the bounding box, it's a bit different than it's the normal one, but that's that. Still, you have the recognition information. And you see more or less what we did here. Let's double check deployment and see that it's running. And let's look a bit again on the cameras. So let's see if they are updating. If there is a hope to see them alive. So what you until we wait for this, you do not see here besides the I-scale lot of business logic. This is a better form solution than the 5G. Here you have just the image processing and getting the inference results out. And this is more or less, I change the number, more or less targeted to IoT devices than the other one. As you can see, yet again, to develop a CAN solution, it's relatively easy. The setup I did not show because, okay, it takes something like in the north of 10 minutes until it deploys and has an issue with the certificates, which you can easily correct. It's again simple. You have the options where you want to run the cluster, the AKS cluster, and besides that, just give names, and you'll get the portal up and running and start doing things. Let's see if yeah. Okay. On the other hand, this part with the images, it's not perfect. You won't get always the latest screenshot and stuff like this. But on the other hand, it's not useful for debugging because you do not have the overlays. If you want to do the debugging of the model, you need the video snippets, which were here, which are in the storage account, because there you have the overlays, you see the bounding box, you have all the information, all the recognition information that there it is. And with this, you can, let's say, make head and tail of what's happened. There is a correlation between what's exported and what's saved on the storage account. And let's get back to the storage account, and let's remind ourselves what's there. And again, I'm still trying one. Okay, it does not open in this manner. So let's still, that seems an empty box. But whatever. Or maybe it has started. Yes, has started. But still, it's an empty box. So getting back, what to say more about this? I'm saying that first, you'll see that it's somehow of a shift of approaches than before. And let us give us a visual cue. And let us show this also of doing this kind of solution. They are for sure container based. Sometimes, okay, they are called even microservice done, even though they are IoT solution, especially in the case of CAN, it's an IoT solution. On the other hand, don't be afraid when you hear IoT Edge. Um, IoT Edge can, needs, will not work on your Arduino, but will work on your Raspberry Pi. So if there are real IoT, lean IoT devices that you can run this. But I've seen the best use of this both solution in taking and harnessing the existing infrastructure. What I mean by that, very much think how many cameras are around. Everything is running RTCP. Okay, yeah, the security it's lax. Even now, you see in my stream, you see the whole credentials and the IPs and all the stuff. Okay, but generally you can get to them. You should change from the defaults from the factory. In fact, that cameras were changed from the defaults from the factory, and they are available. So you have already the cameras, and you can deploy someplace, maybe in the cloud, something that will get insights from the camera. And this is the value proposition. Again, you can run very simple with cognitive services, which I have shown you, which has a very easy entry level for, again, I believe that I closed the pussycats, yes. Well, to show you again, the cognitive services has a very low entry level barrier. There are domain specialists that using cognitive services, they are able to do the labeling. It's not that complex. And that enables you to give the job of labeling to the one who really know what's all about, not to just send you folders with pictures and try to explain what it is. You just leave the one who knows, domain specialist, to do all the bounding boxes or to put all the labels, and then you just train the model, and you'll get it. You redeploy to CAN, and you'll have all the benefits of the model. I'll say in CAN you can also use what you get to retrain the model, but you need again to go to cognitive services to export the pictures, to get what's interesting, and do the stuff yet again and retrain the model. So I'm saying that this is a plateau productivity, because pretty easy you can empower the existing infrastructure with a little investment in, let's say, software, hardware, a lot of investment in imagination, and I believe you can get great results. The area are, let's say, unlimited, from work safety, business, shopping, whatever. Just look around and see how many cameras are around. And everything can be empowered by a similar solution. And you have seen that I run you to all the steps in less than 1 hour. And I needed just an Azure subscription to do all the stuff. And again, if you have the Azure subscription, I said two cognitive services, custom vision, are free, and to run CAN, it's a cluster. It's an AKS cluster. Still, the costs are not sky high. I believe that even with the free one with $200, you can run a good almost whole month on this, running continuously this solution. So let me say the entry level getting to this technology, it's very easy. And if you understand what's all about, if labeling, if classification, detection, it's not no new words, you can reap more benefits. So you coming from the data, which you understand what it's a model, you understand the observability of the model. You are absolutely overqualified to explain somebody to how to do this. And also on this, you do not touch the details. Yes, you say that maybe you want to do optimization. Yes, you can do also this. It will be a bit more difficult to modify the model externally and then get it back, but it's still doable. But if you need to do that, it means that you have the knowledge of getting back getting back into the CAN or whatever model to be run to be used for inference. And to round up the discussion, think again about hardware inference. This is an example. I'll say this will work for one camera, but NVIDIA has very interesting offerings, especially on servers, which are called heavy edge, sometimes by Microsoft, which is able to support something like 20 or 40 cameras and done inference on hardware, which is much, much more fast. Uh, so, yeah, I'll say now it's an opportunity. And with this, let's try some slides like this one. If you have any questions, or if you fall asleep, bear in mind I cannot hear you snoring. Um, if not, let us okay. Put my contact and try to tell you yet again. Look at computer vision solution. Now it's the plateau of productivity. You have all the knowledge to be able to reap the uh, results from this kind of solution. And the results are absolutely impressive. For the stupidest, I won't say stupidest, for application like reading a thermometer, instead of using a specialized box measuring temperature. Even something like this. Think how easy using this it's to you do something. And for sure there are better and more sophisticated scenario than this. All the technology is here and it's working. Okay, you'll say that the person vehicle detection it's but bear in mind was free and somebody did do it just to showcase that the model is more or less working with a controlled data with a very shallow training set, and it's still getting something. And if we are looking about probabilities, yeah, the probabilities are lower in the site, in the second site, which is the, let's say, production. So pretty much, let me check the time and finish with the, let's say, with Khan. Pretty much this is all from me. So thank you very much for your time. If you have questions, you know where to find me. You can ask them now, or if you are shy, you can use my LinkedIn profile. Yes, the picture I'm something like 20 years younger, but that's another story. You still recognize me. I was always prominent. So thank you very much. I'm hoping that the next session we'll do it someplace in Ukraine and it'll be live. So thank you.
Yeah, Katalin, thank you for the session. This KubeAI, I think, is really amazing. The question is, what type of the camera should a person use to start trying this
Any type,
KubeAI?
any type. But I would say if you want to start, the easiest to start it's a camera that it has. You do not need to investigate the RTCP protocol. There is on the instructions. All the cameras supported, but sometimes you need to look into some obscure knowledge base to find the parameter and the passwords. But all the cameras supports it. So if you have a camera that already had in the booklet this information, that will be the easiest tool to start with.
By the way, the question about the security, I can see that you are providing like the user and the password, right, in the RTSCP string.
Yeah.
Is there any way to do it more securely?
No, this is how the protocol works. And there are also cameras without any, but you should change because you have it from the box. There is a almost, let's say, in my experience, most of the cameras have a way of changing the password and the user, and you should change it when you are aware of it. Uh, and this is how the protocol goes. So yeah, protocol depends on the user password, and also you can specify none, and there are camera with none. So yeah, when you get a camera, you should put a user password, and if they are already, you should change it if possible.
Okay, and the question, if a person wants to start using that, and so you need to have the Azure subscription, and let's say if you have the, uh, let's say we have $50 of credit at Microsoft, then the question is, what can we do for $50? I guess it
It,
depends on the quality of the video, right, and a lot of
and
things.
no, I'm not, I'll say, sure how much it takes all the cluster, but I would say it's not a lot. I believe that it's something in the 50s, 60s. More is the storage account and the log analytics associated with it. And I would say customer, it's $200 to start, so you can try it. And bear in mind, all the solution you can run it even on a server on your laptop. So you are not here. You can run it in Azure. The CAN, it's far simpler. You just say you run it in Azure or run it locally. Yes or no. So you can run it even locally. You're not joined at the hip by Azure.
So if you're running it locally, it means Azure is just a bridge.
Uh, yes, it means that some stuff most probably will you'll get in. I'm not sure what we'll do with the storage account. For sure, if you're running CAN locally, you can have the IoT hub locally because it's an edge offering then. So that makes sense. I'm not sure what would be the role of the Azure. And in the other one, uh, you do not use that much, let's say, Azure services. So you use the Kubernetes, everything else, it's Dapper, the light event bus, it's Mosquito, are not Azure components. In this one, let's say the most proeminent, it's IoT Hub. So IoT Hub, I'm getting that you can run on-prem. So I'm guessing. On the other hand, I'm not sure where I will keep the images. If they will try to go to the cloud and create a storage account, or will have a pod with the storage. Never tried locally. So I'm not sure that I can answer your question. My guess will be that you'll run everything locally. That's my guess. In the CAN story. And in the 5G accelerators, for sure, we'll run everything locally. You do not need Azure for anything.
Okay, I got it. Thank you. So I guess that's it. So we are already out of our time, and this session was amazing. Kathleen, thank you for your time.
Thank you for
And
inviting me.
yep. And thanks to everyone who joined us today. I can see that people are still with us. And not to miss our updates or new streams, don't forget to subscribe to this channel where we are going to run our streams to share it with anyone who is eager to learn new. Thank you everyone for coming today. Have a nice evening and be safe.
Thank you. Have a nice evening.
Thank
Bye.
you.